The question is asked in GATE 2018 for 1 mark. The question is on deadlock. Let me read the question. Consider a system with 3 processes that shares 4 instances of same resource type. Each process can request a maximum of k instances. The largest value of k that will always avoid the deadlock is, means we have given 3 processes P1, P2, P3. 3 processes are given and they are saying that they share 4 instances of same resource type, means there is some resource R and we are having 4 instances, means we are having 4 units of R. We are having the 4 units of R. Now they are saying that these 3 processes can request a resource k unit, means k instances. A process can request for k instances. You have to find the value of k, and the value of k should be maximum. Means if I say, let's say start with the normal, like if I say P1 needs only 1 unit of R. P1 needs only 1 unit of R to get execute. P1 needs only 1 unit of R to get execute. P2 also need only 1 R. P3 also need only 1. So 3 resources I have provided. I am having 4 in my hand, but out of 4 I have given 1 resource, and all the processes will get successfully execute because they said they need 1. I have provided 1 easily because I am having 4 and their total demand is 3 only, so I can easily provide. So the answer can be 1. The k value can be 1, but this is one of the answer. The value of k we have to find maximum. So whether it is maximum or not, let's check. If k value is 1, means the demand of each process is 1, I can easily give 1 resource, but still there will be what? It is not the maximum value. K value is not the maximum. So let's increase the value of k. Let's make the value as 2. Let's make the value as 2. Now, what is the meaning of this? Every process says their demand is 2. They needs 2 resources. We are having 4. So what we can do? One is we can give the 1 resource to every process, and the 4th one we give any of the like P1, P2 or P3. The thing is that whenever there is a question like this, whenever the question is asked like this, what you need to do is first write down all the processes, try to give the minimum need, means we are having the 4 resources in our hand. What I did, I have given 1 to all the processes, and the 4th one I can give any of the process. Let's say the 4th one I have given to the P1. So how many processes P1 get? 2. P1 get 2. And what is the need of P1? 2. So when the need is fulfilled, the P1 will get execute. And when the P1 will get execute, the 2 resources will be free. Whatever the 2 resources it is having, that will be free, and that 2 resources I will provide to P2 and P3. So P2 need is also 2 fulfilled, P3 need is 2 fulfilled. So yes, k value can be 2 also. So k value can be 1 also, k value can be 2, but as the question is asking for the largest value of k, so we cannot say that 1 is the appropriate answer, because we find 2 also the appropriate. So now the 2 is the answer. Let's check for 3. Let's say the demand is 3. Demand is 3. Means every process needs at least 3 resources, or you can say 3 resources to get execute. And how many processes given? 3. 3 processes are given. So if it says that I need 3 resources, what we can do? Yes, we can provide like this: 1, 2, 3. Means out of 4 resources, I provide 3 to P1, and the 4th one which is left I provide to P2. What I did, number of resources I have 4. each process needs 3. So out of 4, I pick 3 and I give these 3 to the P1. And the fourth one I give to the P2. Now, you can easily say P1 needs 3, so P1 get 3. So when the P1 get 3, it will be successfully execute, and when it gets successfully execute, the 3 resources will be free. So when the 3 resources will be free, I will give it to the other processes. Like 3 resources I am having free. So let's say I give 2 to them, 2 to P2 and 1 to P3. And now P3 and P2. So P2 also get all the 3 resources. It needs 3. I gave it 3. So it will also get successfully execute and removed. And whatever the resources occupying by P2, they will be free. I will give it to the P3. Then P3 will also successfully execute. So can we say the value of K can be 3? No. There must be, you have to follow all the cases, because there is for always, means will always avoid the deadlock situation. So whenever the question is asked on the always, you have to analyze all the cases. Now let's say the demand is still 3. The demand is still 3. What we can do? Let's say there can be one of the case 1, 1, 1. Out of 4, 1 resource I gave to P1, 1 resource I gave to P2, 1 resource I gave to P3. The fourth one, let's say I gave it to the P1. Now see, P1 needs 1 more resource to get execute. P2 needs 2 more. P3 needs 2 more. How P1 will get 1 more? No, there is no chance that P1 get 1 more. There is no chance that P2 get 2 more. There is no chance that P3 get 2 more. So this location will be empty, because P1 needs 1 more resource. As we have taken the demand as we have taken the request is 3. So P1 needs 1 more, P2 needs 2 more, P3 needs 2 more. Who will fulfill? No, nobody is going to fulfill the request. So in this situation, there will be a deadlock, because P1 is waiting for 1 resource, P2 is waiting for 2 resource, P3 is waiting for 2 resource, and who will be providing them the resources? Nobody, because P1 has taken 2, P2 has taken 1, P3 has taken 1. So what is the meaning of this? Why I have written this? We have to examine all the cases. Don't directly say that K value 3 is the answer. For 1 or 2 cases, K value 3 can be the correct, but you have to examine for all the cases. And this is one of the case. If I take the number of resources as 4 and demand as 3, then there will be a deadlock. So you can say 3 value cannot be the right answer. So what is the value next? 2. Because 3 is not the right answer, how we can take the demand as 4, 5 or 6? We cannot increase the demand, because when the demand is 3 only, still there is a possibility of deadlock in one of the case. So we cannot increase the value of K from 3 to 4, 5, 6. So what is the appropriate answer? The value will be 2. The answer should be 2 only. So if I take the demand of each process as 2, then there is no any case in which a deadlock can occur. No, neither. If I take the value of 2, demand as 2, all the cases will be deadlock free. We can say all the cases will be free from the deadlock. So the answer should be 2. Let's find some other way. This is a manual. This is a manual method. You can follow this method also, but there is another method. Another method to find. Let's derive the formula. Let's say I am having R number of resources. Total number of resources I have R. In my system, total resources are R, and let's say I am having N number of processes. I am having R number of resources, N number of processes. I have written like this, P1, P2, P3 up to Pn. And the demand, let's say the demand of P1 is D1, demand of P2 is D3 and up to Dn. So what we have assumed, let's say R number of resources, N number of processes, and D1, D2, D3 is the demand. So let's derive some formula which is related to all these three. Now if I want that the system should be deadlock free, one thing is I can provide the D1 resource. P1 needs D1 resource, D1 number of resources, I will provide them. P2 needs D2, I will provide. P3 needs D3, I will provide. Means whatever their need, if I provide that, the need will be fulfilled. There will be no deadlock. But here we have to find the minimum. Means it should not be like what is the maximum demand I will fulfill directly. We have to find the minimum number of resources. Means the resources should be less and the deadlock should be removed. It should not be like if there are 3 number of resources, let's say 3 number of processes and 2 is the demand. 2 is the demand. So total will be 6 and I will give the 6 resources. If I give the 6 resources, that is the normal answer. But I have to follow the concept in which the number of resources should be minimum and the deadlock should not be there. So this is the quite tricky, but if you follow it, you will definitely get the clarity. Let's say we are finding the maximum resources I provide according to the demand, but still there is a deadlock. Still deadlock means I am trying to provide the resources to the processes according to their demand, but still there is a deadlock. So this is quite a tricky. Let's say I am having P1, P2, P3. Every process says their demand is 2, means it says 2, it says 2, it says 2. If I provide 2 to him, 2 to him, 2 to him, means total if I have 6 resource, then there is no problem. Deadlock is free because there is no deadlock. P1 needs 2, I provide 2. 2, I provide 2. 2, I provide 2. So total how many resources I must have? 6. But no, this is not the appropriate answer. You have to minimize the value. You should not purchase as maximum resources. You should purchase minimum but free from the deadlock. So how we derive? What we can do, rather than directly giving the demand, their demand is 2, I am not giving 2, I am giving the 1. I am giving the 1, I am giving the 1. Means how many resources I am giving? 3. But now there is a deadlock because everybody needs one of the resource. Everybody needs one resource. Every process needs one resource. What I will do, I will add one more and it will be free from the deadlock. Means if I add one more, if I give like this, means if I give 2 to P1, it will be executed. The resources will be free. It will be given to P2 and P3. They will also execute. So what we are trying to find is, we are trying to find the maximum number of resources we have, but still there is a deadlock. How to find it? Same. The demand is D1. I am not giving the demand D1. I am giving D1 minus 1. 1 less than the demand. Same for this. D2 minus 1. Same for the third. D3 minus 1. Same for the last. Now, what is the total number of resources I have? Total number of resources is whatever the total number of resources, like D summation, just add all the resources, summation of D I, where I is equal to 1 to N, Di minus 1, minus 1, minus 1, it will be up to N. So this is the formula we can derive. So what is this? The demand, the total demand minus N, means this number of resources, these number of resources, if I have the resources, what is the number of resources I have? If I have the resources R and number of resources R is less than equal to this, if the number of resources R is less than equal to this, there will be a deadlock. There will be a deadlock, because whatever the demand, I am not fulfilling the demand directly. I am giving one less than, so there is still a deadlock exists. If I provide these number of R, there will be a deadlock. So our R should be greater than this. If I want to free from the deadlock, means in this case there is still a deadlock. But if I do like R should be greater than summation of I is equal to 1 to n di minus n, in this case it will be deadlock free. Means the number of resources I have provided, that is more than the summation of all the requirement minus n, that is the number of processes. So we can say R plus n should be greater than summation of I is equal to 1 to n di. This is what R plus n is greater than this. What is the meaning of R plus n? R plus n is R is what? The number of resources, total resources, that is R. N is the total processes, total number of resources plus total number of processes should be greater than the demand, the total demand. This is the meaning of this. So total number of resources plus total number of processes in the system, it should be greater than the total demand. Total demand means demand of all the processes. If I provide this, then there will be no deadlock. In this situation there will be no deadlock. So if the question is asked like this, you can solve manually also as given in the previous way, but you can follow this method. What is the method? What is the formula? Total number of resources plus total number of processes should always be greater than the total demand. So let's say, what is the total number of resources in this question? 4. What is the total number of processes in this question? 3. It should be greater than the total demand. What is the demand? The demand should be, let's say, if I say every process demand is like 3 processes are there and every process demands for 2. So what is this? 7 should be greater than 3 into 2, that is 6. It is true. So yes, this is valid answer. So every process can demand maximum of 2. If you increase the demand to 3, let's say if you increase the demand to 3, so what is the total number of resources? 4. Number of processes 3. It should be greater than the total demand. Total demand means number of processes are 3 and demand of every process is 3. So what it is? 7 should be greater than 3 into 3, that is 9. It is false. So the demand of each process cannot be 3. Even if cannot be 3, you can also say 4, 5, 6 is not possible. But if the demand of every process is 2, so you can simply say yes, this is valid. So always remember this formula: resources plus processes. Total number of resources plus total number of processes should always be greater than the total demand. This is the important formula. So we have seen also how to derive this formula, and you don't need to derive it again and again in the exam. You just remember this formula and according to the question you can apply it. So according to this question, now we can apply and the answer is 2. So this is how we have to solve the questions. Like GATE may and other competitive exams may, if the question is asked like that. Let's examine the formula again. Let's say, just binding it, let's say I am having 4 processes. and I am having 4 number of processes, and I am having, let's say, 4 number of resources. I am having 4 number of processes and I am having 4 number of resources. So what can be the maximum demand? What can be the maximum demand? The maximum demand can be like, what is the number of processes? 4. Number of resources 4. 8 should be greater than total demand. So each process, if demand for 1, then 8 is greater than 4. This is valid. Try to increase the demand. 4 plus 4 is greater than each process demand for 2. So what is 8 greater than 8? This is false. This is false. So this is a very important formula. If I am having 4 processes, 4 resources, and each process demand for 2 to get execute, this is false. There will be a deadlock occur. But if every process demand for only 1, there will be no deadlock. You can do it like that also. P1, P2, P3, P4. 4 processes. Each process demand for, let's say, 2. So 1, 1, 1, 1. 4 I have given 2. How can I give the 2? Everybody is waiting for 1 resource. And I have already allocated 4 number of resources. What I have provided it. So there will be a deadlock. So demand of each process cannot be 2. They cannot demand for 2 resources. So they can demand for 1, no problem. If they demand for 1, I can easily give 1, 1, 1 to every process, and they will get successfully executed. So this is how we can solve the questions like this manually also, and by using this formula also. So guys, if you like this video, please share with your friends and your colleagues, and please subscribe my channel. Thank you.